Now let us see the experimental setup wherein which we are taking a transformer which works on the principle of the mutual flux or mutual induction, okay, wherein which we are taking a transformer which is connected to a galvanometer. Here we have a primary and we have a secondary, and in between this we are having a diamagnetism wherein which it has T is greater than Tc, which is a normal conductor, and this is being connected to a battery which is positive terminal to the primary side and negative terminal is being currently switched off, like it has a switch, okay, and this is a normal conductor where T is greater than Tc. And this to measure the current which is flowing through entire the thing, we have the galvanometer. First thing we have to choose here is the penetration of the magnetic flux lines, and the second condition is the expulsion of the magnetic flux lines. We have to see both the penetration of the magnetic flux lines and the expulsion of the magnetic flux lines. This is a experimental setup wherein which we are using a transformer, okay. And now based on the Meissner's effect, the superconductors are classified as two superconductors, two types, that is type 1 and type 2. In the type 1 superconductor we have soft superconductor. In the type 2 superconductor we have hard superconductor. In the type 1 superconductor, if we plot a graph of type 1 super soft conductor, we will be getting a graph somewhat like this. The intensity of the magnetic field is taken on the x-axis and the intensity of the magnetization is taken on the y-axis, which is the negative y-axis. And if we plot a graph, we will be getting in this way, and this is the region of the superconductors and this is the region of the entire thing is the region of the normal conductor. After reaching H, that is after reaching H at a particular time, Hc, the superconductor becomes a normal conductor. So they are called as soft superconductor. Means one can easily convert the superconductor to a normal conductor, and this process is very rapid. That is why they are called as soft superconductors. And the second one, we'll see what is a hard superconductor is. In the hard superconductor, as the name itself says, it is pretty hard to get the reverse. And if we plot a graph of x-axis taking the intensity of the magnetizing field onto the x-axis and the intensity of the magnetization onto the y-axis, we have a superconductor onto the left side and Hc1. We will be getting Hc1 and Hc2. That is the lower cutoff field strength and higher cutoff field strength. Now we have the vortex state, that is the normal conductor. Okay. And this process has to